Hello, I am Iyad Khaddam and I'm here to present my article towards rapid prototyping of foldable graphical user interfaces with Flecto. Foldable devices are a reality nowadays. We can buy foldable products such as Royal Flex Pay, Samsung Galaxy Fold 1 and 2, or Huawei Mate X. These devices enjoy the nice feature of having a large screen on a small device. However, foldable prototypes in research are way sophisticated compared to existing products. For instance, some research prototypes define multiple hinges compared to one hinge in commercial products. Others define innovative interaction techniques such as leafing or zooming in and out through bending. We believe that someday we will be able to buy a foldable widget with leafing capabilities to read a book in a natural way. And why not using a foldable widget instead of a restaurant menu? Besides, some widgets might be more appropriate to play games. As you can imagine, each foldable widget will serve a specific function and will have a dedicated software running on it. So when designing a foldable widget, you need to consider both interactions with the device and how to consume the device capabilities on the software. This couples the hardware decisions and the software ones. Manufacturers may address this challenge by following a try and error approach, but this approach is expensive because we need to build the hardware prototypes several times, not to mention the complexity of the process while dealing with high technology. Besides, they are not flexible when it comes to adding new functionalities. They may suffer from reduced mobility out of the laboratory and complexity in the setup that may involve multiple specialized equipments. Furthermore, on the software part, there is a lack in software development methods, models, and tools addressing UIs for foldable devices. In order to address these challenges and gaps, we introduce Flecto, a model-based approach to develop software for foldable devices. Flecto consists of a model to define foldable devices. That means the physical surfaces and interaction capabilities, a model to develop the UI prototype, a method to use both models, and a tool support for the method and the models. Flecto uses the notation of origami in modeling the foldable device, because it is a powerful notation and it has been largely explored for foldable displays in the literature. Let me present a demo on Flecto. I will first demonstrate the Surface Designer to define the physical device and hinges. First, fill in the surface dimensions and define hinges using the origami notation. The simulator will show the device in 3D. Folding hinges may trigger events in the UI running on the device. To define an event, select a hinge, give it a name, and an open or a close angle on when to trigger the event. Flecto can transform a static UI into a foldable one. I will demonstrate a brochure for selling a property. The device can be folded in the middle, creating two surfaces. The simulator generates automatically a form for each surface, giving the ability to assign a sketch to each. The simulator updates accordingly. Flecto can transform an executable UI into a foldable UI. Assume we have a 2D UI for browsing scientific articles. On the first page, we see the title. Click on More to see the abstract, the table of contents, and the references. When you start reading, you can browse the pages by clicking on the buttons Next Page and Previous Page. The foldable device is an A4 paper that can be folded twice in the middle. Once fully folded, it displays the title and the authors. Once opened at 30 degrees, The device triggers an event on the UI to adapt the projected content. On the face, we see the abstract and the table of contents. On the back, we can see the references. Now open the device completely to start reading the content of the article. Navigate through the content by bending the corners on the top to move forwards or backwards. Flecto provides a two-way binding of events. You can interact with the projected content as if interacting with the 2D UI. We'll demonstrate this by clicking on the scroll bar to move lower on the projected page. We'll do it again to scroll up. We can fold Flecto back to its initial state. In order to get a meaningful feedback on Flecto from users, we conducted an experiment on 13 researchers. We used the Microsoft product reaction cards to capture their feedback. This cloud represents the impression of the participants on Flecto. It illustrates the three keywords: creative, motivating, and intuitive. This concludes my presentation. Thank you very much for your attention. And one last thing, Flecto is an open source project on GitHub.